This is a demonstration of our laser harp by Group 6, a unique musical instrument designed without any mechanical strings. Instead, it uses laser beams as virtual strings that trigger sound when interrupted. The project blends hardware and software, showcasing key principles in photonics, motor control, and embedded audio. In this video, we'll walk through each major component of the system and demonstrate how they come together to create a fully functional prototype of a laser-based instrument. In this demo, we're showcasing a working prototype of what the final laser harp will be capable of. This setup uses a simplified version of the core hardware to demonstrate the essential functions, detecting when a laser beam is interrupted and playing a musical note in response. The prototype includes components for generating laser beams, detecting interaction through light sensors, and producing sound using an audio system. While it's not the full version yet, this prototype highlights the foundational technology that the final harp will build upon, giving us a clear path forward for refinement and expansion. The audio system is responsible for producing sound when a beam is interrupted. It includes the DF Player MIDI module, a 32GB micro SD card, an Arduino Uno for control, and a small speaker for sound playback. Musical notes are stored on a memory card and played instantly when a signal is received. Here's a demonstration of our prototype audio setup working in real time.
So this is a prototype of the audio system. This is just using the microcontroller connected directly into the DF Player Mini, which will be the audio storage for our final product. Currently, we have a micro SD card plugged in, and connected with it for the actual development board. We used a REX Qualis. It's an Arduino. It's similar to the Arduino Uno board. So with that, we connected the serial UART input output directly into the board, and used the speaker driver on the DF Player Mini. Currently, we have a sound plugged in, and we have all the ground and voltages plugged in. So to test it, this is the code here on the monitor, and we will just upload it. All right, it's uploaded. And
To simulate multiple laser streams using a single beam, we are using a rotating mirror system powered by a NEMA 17 stepper motor. This motor is controlled by a TB6600 driver, which provides the precision and torque needed to move the mirror in small, accurate steps. As the motor rotates, it fans the laser beams across multiple positions, allowing us to create the illusion of separate strings. Here's a demonstration of our motor and driver setup in action.
This is the NEMA 17 stepper motor. We are using a TB6600 driver to power, and we're using our Arduino to control the steps. So for this one, we are moving approximately like 70 degrees forward and then backwards, and stopping intermittently in between. The steps are going to be 22 steps, and ideally, in the final project, there's going to be a laser flashing every third step. Now this is the stepper motor with the mirror attachment. There's going to be a mirror here, and the laser is going to be flashing, and the strings are going to come out upwards.
Our optical setup showcases an interaction between the PLT3 520D laser diode that emits the beam and an FDS100 photodiode that detects when the beam is interrupted. Here's a demo of how the laser and sensor work together in real time.
Okay, so for the laser setup, this laser is not the laser that's going to be used. It did not come in time. The one that is used is referenced in the document. For the photodiode, we are using an FDS100, and then this is the collimating lens that'll collimate the diffused light into the photodiode. For a surface, to get the diffused reflection, we're using a business card. And then, so I'm going to shine the light, or place the business card over the laser beam. It'll cause the diffused reflection, and it'll get focused into the photodiode, and we'll see an output in volts on the screen over here. and we are following ANSI standards. There is a beam dump placed above the beam so it is not hitting the ceiling, causing stray reflections. Okay.
This prototype demonstrates the essential functions of our laser harp, from detecting beam interruptions to producing sound in response. As we continue development, we'll expand the number of strings, refine the controls, and enhance the user interface. Thank you for watching our demo, and we look forward to presenting the final version soon.